Okay, guys. This is the compressor. The compressor receives vapor, low evaporated, and send vapor supersaturated compressor. And the compressor have two elements, electrical elements. Can you refresh me the name of those elements? What is the name of the first one? The current coming from the breaker enter here.
Thermal switch.
In the thermal switch. Look at this. After that, the current enter in this element. What is this?
Relay.
With three terminals. All of the compressors, if you check this compressor, guys, you check this compressor, they have in the bottom the thermal and on top the relay. What is the name of that relay? Compressor relay. The compressor relay. The compressor relay. The compressor relay. All right, this is the compressor. The compressor have two pipes. One pipe big one and the other one smaller. The smaller pipe is for high pressure, for discharge. And the big one is for suction. All right, the blue one. Ready, guys? Pay attention. Immediately, the gas is going out from the compressor at high pressure. You have the feeding. You have the feeding for the gauge, and you have also other feeding for the high pressure switch. And immediately goes out the high pressure line, enter in this accumulator. What is the function of the accumulator, guys? Absorb moisture with this. Thank you. With this. What is the name of this?
Desiccant.
Desiccant. Thank you. Normally in this container there are two of these. One here and other here. Over there. Inside of this. Those elements absorb humidity like the rice. Absorb humidity. This element have two functions. Absorb moisture, and the second one, absorb vibration and turbulence. In some air conditioned units, there is one in the output and other one before the refrigerant return into the compressor. In some cases, in some designs. Everybody follow me, guys? Yep. What is the name of this? Accumulator. Or receiver dryer. Receiver dryer. Thank you. And inside of this, we have a couple of desiccant. Thank you. Okay, guys. After that, the refrigerant continue at high pressure. In this moment, is a little, a couple of inches after the accumulator. Right now, it's not a vapor; it's liquid. And continue liquid, pass for the dryer, the second dryer. You remember the second dryer, guys? Filter dryer. And after that, enter into the expansion valve. And the expansion valve is basically the capillary pipe. The length of the capillary pipe and the diameter of the capillary pipe depend on what? Depend on the size of the evaporator. In other words, that amount of capillary coils and the diameter is calculated for this evaporator and this compressor. In some cases, if you want to replace the evaporator for a bigger evaporator, you call the manufacturer and they say, okay, you can, but you need to replace the amount of capillary coils. And you need soldering. Of course. Okay, after the capillary pipe, the input pressure and the input temperature of the refrigerant, you remember the input pressure? 225 and the temperature?
Around 110.
After that, the pressure is around 70 psi and 40 degrees Fahrenheit. If you keep in mind those numbers, that's nice. That's universal. In all air conditioned units, it's exactly the same. Excuse me. In a refrigerator, the pressure and the temperature before the expansion valve is low. And of course, after the expansion valve is ultra low. And this is why I have ice in the evaporator. You know? That's the only difference. All right. Okay, guys. Immediately after the expansion valve, after the capillary Garfield, is liquid. but a couple of inches later start to evaporate. In other words, in the bottom of this radiator start the process of evaporation. Start the process of evaporation. And additionally, when this fan starts, the ambient air at 86, 85 degrees Fahrenheit pass through those pipes and help to evaporate faster. No? In other words, what happened with the refrigerant in the output on top of the evaporator? It's completely evaporated, super saturated. And it's evaporated, and enter again in the compressor. The feeding is here to connect both of them, the gauge. This is why you have one feeding in the low pressure side and other feeding in the high pressure side with the color blue. In each of those feedings, we are going to connect our, for example, in this moment, I connect the red hose in the high pressure side. How much is the pressure here?
150.
160. 160.
Yes, sir.
We are going to connect the low pressure side. Remove the cap. The camera. Hard, quickly. Quickly. Yeah? To avoid release too much refrigerant, no? And you tie like a man. Okay. Oh wow! In this moment is excuse me, 130. This is 134A. Is around 90 psi in the low pressure side and 140 in the high pressure. But it's not running. It's off. It's off. Okay. If that unit was recently removed from the boat, if that unit stay out of the boat 2 months, 3 months, the pressures will be equalized, both of them equal. In this moment, you have different because was working 2 weeks ago. All right, and what about this hose, the middle one, the yellow one?
The tank.
For the tank. Ah, okay. If I want it, I connect this one to the tank. Pay attention. I connect this one to the tank. I start the unit. I want to add it a little amount of refrigerant, Leo. Okay, guys. I start the unit on the thermostat, and how, from which side is recommended added the refrigerant?
The low pressure?
No.
From the low pressure side. Okay, with the system running,
side, yeah.
I continue check the pressures. Okay, the pressure is in between 60, 70 in the low pressure side, 150, 180. In this particular 140, 120 in the high pressure side is low. Okay, with the system running, I open this one, and what happened? Look at this. This element, the tank, is connected here as I open this. The fluid enter here and enter in the low pressure side of the system. With the system running, I see that the gauge in the low pressure side is stay in 60, 90, 60, 90, and this one increase around 190, 200 psi. When the system is around 100, 200, I tight this, I close this, and I continue running, and I check the air out. Oh, that's great, it's too cold. And the low pressure fluctuate in between 60 and 90, and the high pressure fluctuate in between 150, 200. That's perfect. I added.